Hey everyone, I'm David Bombal. If you don't know me already, I'm very happy to say that Hank Preston from Cisco is doing another call with me discussing various Cisco topics and emerging technologies. So Hank, thanks very much for your time last week, and thanks for joining me again on this call.
Absolutely. I had a great time last week, and I'm looking forward to today's conversation.
So Hank, I've heard a lot about Kubernetes. It seems to be one of those hot topics that a lot of people are talking about, but it seems to be like something that's got nothing to do with networking or Cisco. But you've told me that you have you showed last week, you've got a Kubernetes and ACI lab on DevNet. So could you spend some time explaining what Kubernetes is and how that's related to Cisco?
Absolutely. And I can see how all of the confusion around kind of the interest level or the relevance to a network engineer around Kubernetes or containers in general can come through. But frankly, networking is as important to Kubernetes as networking was to connecting physical servers and then later virtual machines and containers and microservices, which is what you're dealing with Kubernetes. Well, they need a network almost more in some ways than the traditional applications and pieces go through. And so there's definitely a play for traditional network engineering. And then if there's a play for network engineers, obviously there's going to be a play for Cisco. And so we can see how those go through. But before we dive into the bowels of Kubernetes, it's kind of important to understand the building blocks around these microservice apps in Kubernetes, and that's Docker. And so maybe we spend a little bit of time talking about Docker first.
Yeah, that'd be great because, as you say, I mean, I've heard a little bit that Kubernetes is an orchestration tool for Docker containers. But yeah, if you don't understand what Docker is and what a container is, and you've used another term there, microservices. So would you mind, telling us what those are, and then coming back to Kubernetes?
Yeah, absolutely. So a lot of people like to say that a container is this evolution in abstraction and making the workloads smaller and more portable that we've seen. And kind of that first step was x86 virtualization with VMs. And the analogy is good as far as the movement goes, but some of the underlying technologies and how things work, that's where some of the pieces go in. So at its core, a container, and this is going to be Docker containers or other container technologies, because Docker is not the only guy or option in town when we talk about running containers. They just happen to be the most popular. But at its core, what a container is it's an executable. It's a running binary that is built by developers and software providers that package up all of the things necessary for that application to run. A container is actually more closely resembles like an executable, an exe file or something like that, than a virtual machine in how it's packaged and delivered. But what you get out of it is more than just kind of running Notepad or running something like that. What you get inside of a Docker container while it's running is the application code for the whatever the developer is trying to do, plus all of the things that application code needs. And those are often called dependencies. So let me give you an example. Most of us these days have worked with Java-style applications. And one of my first jobs in IT was running around helping people get, I had one customer particularly that had this tendency to always click the upgrade Java button on their workstations, but their application actually required a very specific version of Java to function. And I heard you chuckle a little bit, David. You may have seen something like this in the past.
Yeah, my experience of Java is not, not that great.
Well, I don't want to disparage Java. Frankly, Java is about everywhere these days, and it's core and fundamental to a lot of apps. But what's unique about Java and the way it works is a lot of software that's written with Java does get, unfortunately, tightly coupled to the version of Java that it runs. And so for this application, we need this specific version of Java. And so what I did is I spent, months, it seemed like. Every couple of days, I'd have to go back to this customer to downgrade and uninstall the version of Java so that their application would work on their workstations. It's that type of dependency isolation and kind of linkage to the software that containers try to tackle for user or for developers and for operations teams deploying this. And so when you run the executable that is a Docker container, not only do you have your code, your application, but you would also, in the Java example, have the very specific version of Java that your application needs kind of packaged up with the code itself. And so it's more than just Java. We see the same thing in Python. And so let's say you write a Python application. Most Python applications these days take advantage of different Python libraries. You maybe pip install requests or a database plugin or some connection client. And so if you want to containerize your Python application, you would take your Python code as well as all of the different libraries and modules from Python that your application needs and package them all together into this Docker image, which would run as a container. And now you've kind of locked in step all of the dependencies that your app needs with your code in this very portable single thing that can be run, and that is the Docker container. And some of the terminology gets in there. The way I describe it is a Docker image is a template. A Docker container is a running instance of that template. And so as a developer, I would build an image for my container, or build an image for my application, and then the operations team could run that image out there. And so, for example, I've actually got one of these running over here. So we'll switch over to my workstation. And so if I do Docker PS, and so PS stands for process. And so this is looking at the different Docker processes running on my laptop. And we can see I actually have 3 of these. I have 3 running containers, and they're all given these unique identification pieces. And we can see I started them about an hour ago. And these represent a microservice application. And so let's talk about what a microservice application is for just a second so that we kind of demystify a bit of that term. So what a microservice, the idea behind microservice applications is that most large enterprise apps today have lots of things that they need to do. Maybe you've got a data element of this application, and then you've got an API entry point, you've got user authentication, maybe you've got some business logic that validates the incoming data is accurate, and then you probably have different front-end services. You've got a web interface, you've got something that might deal with mobile applications. Maybe you've even deployed voice services so that folks can work with your application through a device like an Amazon Alexa or Google Home or the Siri pieces. Each element of that application could be considered a microservice, and they're then broken apart and kind of work independently. And this is different than how kind of the traditional applications might have worked, where all of these different elements of the application would be packaged together and kind of run as one, maybe on one virtual machine someplace. With these microservice applications, each of these individual, I like to call them atomic elements of your application, are kind of pulled apart, packaged as independent entities, and then run oftentimes as containers today as they go through. Does that part of kind of microservice and container interaction, does that make sense, David?
Yeah, I think you made a really important distinction there, because the way that Docker and containers has always been explained to me is it's this evolution of a virtual machine where you get rid of the operating system and now you're just running the application on a single operating system. So if you had like 5 VMs in the past, you'd have 6 operating systems, whereas now you've only got 1 to run 5 different applications. But you've said it's more than that, because it's packaging all the dependencies and all the other things that that app relies on together. So you could have multiple applications with different dependencies, and they'd all run hopefully okay. Is that right?
Exactly. Yeah, no, you're spot on. And the evolution of virtual machines tried to do the same thing. But as you mentioned, with a VM, I might do the same thing, have my code, have all of its dependencies running on a virtual machine. But in addition to my code and the dependencies, there's Windows, or there's Linux, and there's Notepad, and there's all of these things that are not needed. And so a lot of people do talk about that stripping out all of the unnecessary crud when you go to containers, which is absolutely true. But the part that I like to focus in on, because this ties into where the networking elements start to pop up, is this idea that what you have with a container, and why they're called processes here in the screen, is because each container is actually just a running process. It's like an executable that's running on the host that's providing kind of the engine to run all of these containers. And so for me, that's an element that's important for network engineers to kind of figure out, is that if you think of a container just like a virtual machine, you can go down paths that may not mentally make a ton of sense. But if you think about a container simply as a process, it's an executable. It's like starting up Notepad or Word or some application on your workstation. Now you start to see some of the problems that go through is because it's not just, in this case, what I have is I have three different parts of this application. I have the data service of this application, the application or the API service of this application, and then the UI or the web front end of this application. Each of those are just a single running process on one computer. And then because of that, now we start to run into, well, how do I isolate? How do I connect these processes together? How do I get visibility between what used to maybe originally had been three different virtual machines talking to each other? And we pretty well understand how to network virtual machines together today. But rather than, I don't have a virtual network or virtual switches or OVSs between these different processes. All I have is kind of what's under the hood on my running workstation. In this case, it's a Mac, but it's the Linux underpinnings is kind of where Docker pops up in this case.
Yeah, so that's a great example. So forgive me for showing my age here, but I remember years ago doing VB6 development, and they started talking about three-tier applications. And that kind of, as an analogy, seems to be what you've got here, where you've got a UI, you've got, say, business logic or the app portion, and then you've got like a database or some kind of third portion to it. But they would, in the old days, be running on three separate computers. So you'd have like a UI running on a web server, you'd have your business logic running on some server, and then your database running on a third server. So is it correct as an analogy to say that's kind of what you're doing here, but these are three separate processes running on one machine rather than three full-blown bare metal computers running applications?
Exactly. Yep. And that's kind of the evolution. And this application, which I call the My Hero application, I actually built it to help understand and explain kind of this evolution from client server applications through microservices. So we're actually kind of, as we go through these demos and this discussion, we'll see how we tear apart a little bit of this concept that this is a three-tier app, because what we've got here is not a three-tier client or web app data application. It's the minimum set of microservices to run this app. And so this is running on my laptop, and I can actually switch over so we can take a look at this running app here. So let me go find it. Here it is. So what we've got is we can see that I'm targeting localhost. So that's the address that I'm going to. And so it's running on port 15080. So real quick, I'll switch back so we can see which one of these microservices I'm talking to. And so we can see the My Hero UI microservice, so that's the container name. We can see right here is where that's that port 15080. And so this is the first bit of some of the networking that Docker is doing under the hood, is I'm running a process, right? It's just an executable on my workstation. And I've gone ahead and inside of the container engine said, okay, any traffic that comes into my local host 0.0.0 on port 1580, I want to kind of translate that, or in networking terms, kind of NAT or PAT that to port 80 from this container, right? And so that's where this is going through, which is why when I bring up this web page, we're seeing a web page, because that's what the UI service is. It's a front end, and it displays kind of this little voting application. So what this app does is it lets you vote for your favorite superhero. And so we can see a bunch of the different heroes, including Captain Cloud and Spider-Man, and we're bridging the gaps between Marvel and DC. But I can place a vote for one of these guys. So we'll vote for Captain America here. And we can see now I'm looking at the voting results that are here. All this portion is this is just a web UI. It doesn't have access to the data. It doesn't actually even know how to place a vote. All it knows how to do is to send an API request off to what is the app service. And so the My Hero app service is an API layer that can consume votes from different types of locations. And in this case, it's consuming it from the UI. And the API tier is running again on my local machine, 0.0.0, and it's running on port 15001. And so now we get into some of the API pieces. So I can test this service right on my workstation by just using curl. And curl's a Linux utility for making web, like HTTP requests. It's used a lot for just testing or pulling down files from a command line. But I'm going to go ahead and send a curl request. The -H is so I can set a header value, and this is the authentication for an API. And so the authentication key for this one, it's actually dev app. And then the address I want to send to is going to be right here. So it's going to be, this is the address for this process or this container. And then let's say I wanted to get the options that are available to vote. And so that's just options. And so I'm making a REST API request to a running container on here, and it pulls the options back. And that API request is the exact same API request that front-end service made to this process to display the options that were there. Is that part, you following? Does that all make sense? Any questions so far?
No, I'm trying to keep quiet to let you, I don't want to interrupt you. So,
okay.
That makes a lot of sense. I mean, the web UI portion is like a web server, and then this is, in the background, it makes an API call using this port number 15001 to the app server. You've just demonstrated that again using a command line rather than using the web interface, but it's essentially the same thing happening in the background when we go to that web page kind of thing. Is that right?
Exactly. And what it is this is an example of kind of what we would typically call the development environment for a software developer, is running the entire application locally on my workstation. And so the application service that we requested here, it doesn't have the data. It has to request the data from the data service, which is that third container there. And it actually uses a REST API to do that, and it would target it in a similar way. And so this is the fundamentals of how kind of a container works, or a Docker container works, is they run as individual processes on a host someplace. And then we use the Docker, the container engine, the runtime that runs on our workstation, allows this kind of network traversal. So incoming network traffic to the host, in this case my laptop, is then natted back or padded back and kind of assigned to these individual processes that are there. And that's the part where the networking starts to come in, particularly when we say, okay, I don't want to deal with this from a development perspective. I want to put this application out in the real world, in production, so that people could actually kind of access and work on this. And that's where we start to get into, okay, some of these other areas, because we don't want to be working off of these just random ports that are assigned, right? Oftentimes a network engineer will say, well, that's great, but port 15,080 is not the port that a user would expect their web application to be running on. API requests need to go through. An often question will come through is, on a development perspective, running one version of the UI and one version of the application services, that's fine for development. But in production, we'd want more than one of these. We need resiliency, and then we need kind of load balancing and proxy services to pass between those. And so now we're getting into the realm of where Kubernetes fits in. Because Kubernetes is what's often called a container scheduler, or a container orchestrator. And so what Kubernetes allows you to do is to actually link together a whole farm or a set of nodes that can provide the ability to run these Docker containers, and then also control the incoming traffic that goes through that. If you've got familiarity with virtual machines, let's say VMware's a kind of ecosystem of tools, the Docker element of this would be like a vSphere host, an individual virtualization host running VMs. Kubernetes starts to fit into kind of at that vCenter level, where vCenter is actually managing kind of all of these farms of vSphere hosts, figuring out where to put a virtual machine, when to start them, when to move them, control how they work. That's kind of what Kubernetes does for the container world, is it says, okay, I have a whole bunch of what are often called nodes or workers that can run containers. And Kubernetes lets us figure out the best place to put them, how to deploy security to them, and all of these other pieces on that side. So I'm going to move for a second. I'm just going to clear my screen. So I'm still on
Before
my
we move
local...
on, can I just can I ask you a few questions?
Oh, absolutely.
Do you mind showing those 3 apps again?
Mm-hmm.
Just want to make sure that I understand sort of the evolution of this.
Yep.
So would it be correct to say, and I'm going to use some terms that I've heard, and I want to try and relate it back to a networking guy's perspective.
Mm-hmm.
In the old days, we had what were called monolithic applications. So you had one executable or one app that did everything. So it was the interface. in those days you didn't have a web UI. You would have like a Windows interface. So the interface was there plus the business logic. So like your app portion plus the database. Everything would be contained in this one application. That didn't scale. So then they moved to like this 3-tier application idea where you, instead of running everything on one server, you split the logic across 3 servers. So you have like your front end, your app, and then your database, each on 3 servers kind of thing. But then so those were 3 physical servers. So just correct me at any point if I'm talking nonsense. That then evolved into like VMs, because there's a lot of advantages to using VMs. So rather than having 3 physical servers, I might have 3 VMs running on ESXi or multiple ESXi servers. And then what you're saying, this has kind of evolved even further now, where we're getting rid of VMs. So rather than having, say, 3 VMs, we've just got 3 processes, which could be running on one server, like in this example. But in production, it would run on, say, different servers. And then you would manage VMs using vSphere and vCenter, but Kubernetes allows us to do the management portion of containers. Did that make sense, kind of thing?
That's perfect, and that's kind of a great summary and kind of bringing us back to where we are, because you hit it on the nail on the head. Everything that we've done from those monolithic single applications up to today's microservices, and then where we're headed next is kind of this concept of function as a service, but I don't want to go down that path today. We'll stick with containers for now. Is this kind of goal to simplify and break down and allow our applications to scale and make them easier to develop and be more agile. And it's just these stepwise improvements in efficiencies and isolation is kind of what each of these tiers have given us.
Yeah, so taking it back to a networker's point of view, it makes a lot of sense if I think of these 3, what you would call microservices, which is kind of like a little application type thing, providing some kind of function or some kind of service, as an analogy going back to the old days where I've got 3 applications running on 3 physical servers, and I have to put networking between them. So in the old days, I used to have a physical firewall perhaps between my different servers, and I would create access lists or firewall policies to permit or deny traffic between certain servers. Then when we went to VMs, we can use a virtual firewall. So we could use an ASAV or a Linux firewall to put policies between them. But now I'm getting lost now. So you're going to hopefully tell us at some point now a network guy can get involved in these microservices to join all of this virtual processes together and kind of implement some kind of policy. Is that right?
Exactly. And now we're starting to get into kind of where the value of Cisco and other networking vendors and networking intelligence coming into the container and the Kubernetes space. And that's kind of where we're going to head, is because you're starting to see that piece. If we think about when we first went to virtual machines, originally, right, all the VMs just kind of sat on the same vSwitch and they talked to each other. And if we wanted isolation, we had to break different virtual machines onto different virtual hosts, and then we put firewalls between physical servers. And then every VM that was on a physical server kind of lived in its own security zone. And then eventually we got more intelligence inside of the virtual switching layers so that we didn't need that type of segmentation. We could do VLAN segmentation, or we could even do kind of security segmentation kind of at the hypervisor level with virtual firewalls and the like. We're kind of at that same spot in the container space now with trying to figure out how do we add network intelligence inside of these hosts? So let's take the next step up. So this first command I ran here, this docker ps, this is looking at the Docker containers running on my laptop. It's my MacBook that's sitting here. I've got some Docker containers on there. Now the next evolution is to deploy this application to a production cluster. And for us today, that's Kubernetes. And so I have this app running in a production cluster. And so my commands that are going to change a little bit, instead of using Docker as the commands I'm going to use kubectl, sometimes pronounced as kubectl, or lots of different ways to go through. So we're going to use kubectl, and I'm going to say git deployments. Okay? And so the concept of a deployment inside of Kubernetes is this idea of a deployment is a tier of an application or a microservice of an application. And so I've asked Kubernetes to say, okay, what microservices or what applications have we deployed so far to this cluster? And we can see I've got several deployed. We're going to hone in on these ones that all start with My Hero initially, because these are the microservices that relate to the My Hero application specifically. And so we should see some that are familiar. We see the data service, we see the app service, and then down at the bottom is the UI service. But in addition to that are other microservices. Because as I hinted, the three, the UI, app, and data, are the minimum microservices necessary for this application. But there are other microservices that can be used. For example, we've got Ernst and Mosca, which are actually kind of a voting queuing service that go through. And then I've got a Spark, which in this case is WebEx Teams, that allows me to chat rather than use a web interface. And then Tropo gives me the ability to use SMS text messaging to vote. And so this is where we start to see this microservice, I don't want to say explosion, but the additional microservices come through. Because there's more than just this is more than just a 3-tier app. It's actually, at this point, we're running, what have I got there? 7 tiers to this application. And this is kind of that idea of microservices. So does that bit make sense so far? Kind of this translation into different microservices from 3-tier?
Yeah, I mean, so just to make sure I understand it, in the old days, just taking back because of my age, we used to have this one application, but it was difficult because only certain people could work on this application and develop it. But now with microservices, different developers can concentrate on different parts of an application.
Yes.
And then they can just say this is providing a function or a service. So like you mentioned queuing, so you could be writing the queuing function while I do the graphical user interface, and you just tell me how to send things to you, like the APIs to use, and then you take care of it, and then you do something based on what I'm sending you. So we've got this split of work. And when you talk about microservices, I get the understanding that it's a small service rather than this huge monolithic service that's providing a specific function or service. Is that right?
Exactly. Yeah, the idea behind microservices are they can be independently worked on, as you mentioned. You can work on one, I can work on another, and we just agree on how we talk. And then they're called microservice because the idea is that they're packaged in size and appropriate, that it's a reasonable amount of stuff so that you can work on it independently. It's not super complex, so it's easy for developers to iterate. So that's that microservice idea behind it. So you've got it right on the head there. And in this case, I've got 7 microservices running. But the deployment that we requested, the deployment isn't actually a container, because what you'll see here is some of these, for example, the app service has got 10 listed for desired, current, up-to-date, and available. That 10 is an indication that I actually wanted to scale this microservice up. I didn't want just one container. I wanted 10 of them so that I could have some resiliency and kind of scale. So I'm going to run a new Kubernetes command, kubectl get
Can I just
pods.
interrupt you there for a second, Hank?
Oh, sure.
Sorry, I was going to say the other thing I've heard now that you've mentioned, like you've launched multiple containers or instances or whatever term you're going to use for that microservice, is I believe another advantage of containers and microservices is you can spin them up, is the term people use, spin them up and spin them down very quickly. And in layman's terms, correct me if I'm wrong, that just means they boot up quickly. So rather than booting up Windows, the whole operating system, and then DNS and DHCP and all these other crazy services that you don't need, it just boots up that single service that you require, which is that app service. So it boots up very quickly. Is that kind of correct?
Yes. Yep. And that's kind of the nature of that, the fact that the container is a process and not a virtual machine. It's just it needs to run an executable. Much faster to do that than boot an entire operating system.
Great.
So let's talk about those running instances. And in Kubernetes, we're going to call them pods. A pod is a Kubernetes term that is kind of an atomic unit of work. And a pod is everything that it takes to run an instance of a deployment. And so oftentimes that's a container, but in complex applications, it could be more than one container per pod. But for us, we're going to think about it as one container. And I'm going to do -O for output. So I'm just going to say, give me a wide output. Show me kind of all of the details about these running pods. And so now when I run this one, what we see now is I'm actually seeing the list of every container that's running on this Kubernetes cluster. And so right here in the middle, we can actually see this block of My Hero app. And so those are the 10 instances of the My Hero app deployment that's running. And so what you'll notice, hopefully you've already seen, is each one of these running containers has an IP address. right?
Yeah.
Each one of them has a separate IP that goes through. Now, this is, again, where some of the networking comes through. So how do, inside of my applications, right, I don't want my UI service to have to know 10 different IP addresses, because what about if we scale that up and next I've got 20? Now I have to tell 20 IP addresses to a UI service, right? That doesn't make sense. It's not like that problem is a new one. For containers, we've had that since the old days of kind of client-server 3-tier apps, where we would kind of have load balancing that goes through. And Kubernetes provides us that same type of capability. As Kubernetes can say, okay, I want to load balance or provide access to what we'll call the MyHero app service. And so there's this next command we'll run, which is kubectl get services. And so now we're getting a look at what are kind of fundamentally these load balancers that provide access into some of these pieces. And so the MyHero app service has what's called a cluster IP address. And so the cluster IP address is one address that within the Kubernetes cluster, we can access all of those different containers. And so if I'm one microservice, all I need to target is this 10.3.247.202, and then Kubernetes will handle kind of moving those or distributing those across all of the potential containers that are running. And so again, networking is fundamental to how any of these container technologies work, because we have to network together all of these running processes, because each process is accessible because of a network address. That's how all of these containers are working, is through these kind of network level kind of connectivity that goes through. And so hopefully already it's pretty clear networking is kind of fundamental to containers on that side. Have I convinced you to that piece so far, David?
You have, but you've also made me really worried, because it was easy in the old days when I started, where you had physical servers and they didn't magically just jump around around a data center. So I'm hoping at some point you're going to tell me Cisco have got a solution for this, because when I look at this and think of traditional access lists and firewalls, I can't go into the data center and move a physical firewall around every second as you spin these things up and move them around. I mean, taking it back just a bit of what I've learned about VMs, with vMotion, it was a nightmare with traditional networking, because you were moving these VMs around. And now what you're telling me, it's even worse now, because you've got not just VMs moving around, you can spin these things up instantly and pull them down instantly. So I'm hoping we've got a solution for the poor network guy that has to try and put some kind of security behind all of this stuff.
We absolutely do. So I'm going to make it even scarier for you for just a second. And so
thanks.
Because this is going to lead directly into that discussion we want to have about kind of what can we do, kind of what is Cisco doing to try to make this go through. So I'm going to just scroll up in my window a little bit back to these individual pods. This thing at the end of the table, this node, this actually represents a worker node. And so I'll call it a server. These are running up in Google. So these are Google VMs, right? The equivalent of a Google virtual machine that is providing this service that goes through. And there's several of them in here, and they're named really funny because of the whole kind of like don't pets and cattle with your VMs and all of those. But I've got several different what we'll call nodes in behind here. And all of these nodes are kind of connected together inside of Kubernetes in what's called the Kubernetes overlay network. And frankly, every one of these, we can see each of these pods has got an IP address kind of in this 10.0, and then it does go up, I think, or 10.0, I think it's a /16. So 10.0 anything is this one gigantic network space that as pods come up are just randomly assigned an IP address by Kubernetes. So you spin up a new pod, Kubernetes gives it a new IP address, and they all exist in this one layer 2 segment. And so let's not even talk about the issues with that large of a broadcast domain, because those are there, but there is some efficiencies done kind of in containers to simplify some of those pieces. But for me, what that means is, let's say that my application, because this is on the public internet, I didn't even mention that, but you can hit this running application from this cluster. So I'll switch over back to Chrome for just a second. And if I go to this address, myhero.imapex.io, this is actually that same MyHero application, but running off of that public internet Kubernetes cluster. So this is an application on the public internet. And now, as we know, the public internet is a dangerous place to go. Constantly our vulnerabilities and web applications being found, things are getting compromised. And so the thing that jumps out to me always when I think about this is the fact that my hero UI, right? These two little services down here that I just highlighted, these are web servers that are sitting on the public internet. If those web servers were to be compromised, maybe there's a vulnerability in the underlying Nginx that's there. Well, those web servers are on the exact same kind of network segment along with the application services, the queuing services, and even the underlying data service for this application. And if I had hundreds of business applications all running here, they would all be on that same network area. And so this is where that concept of segmentation, or sometimes micro-segmentation, starts to come through, is this risk that pops up is, I don't want all of these things there. You've already made this assumption that we've got firewalls between these tiers. In many Kubernetes deployments like this, that's not a trivial task to do. And there's some very strange architectures that are sometimes built and deployed and inefficiently done, because the only way many Kubernetes clusters can do this is by saying, okay, my UI ones, I need to put those on an isolated cluster someplace so that I can put a firewall between them. But efficiently, we don't want to do that. I want to be able to just put these guys anywhere. And so that's where I want to go next, is to talk about what we can do when we can combine Cisco's ACI solution for the data center, which provides network connectivity for physical servers and virtual machines, but can also do it for containers so that we can get visibility and segmentation all the way down here at the kind of the container level. Does that sound exciting?
Yeah, I think the takeaway for me as a traditional, or someone coming from a traditional routing and switching background, is the stuff that we used to just won't work in a data center of today. Firstly with VMs and vMotion, but even more so with this stuff. Because, I mean, I can't edit access lists or, as you say, put firewalls between all this stuff, because this is happening dynamically. And you're saying this stuff just spins up and can spin up anywhere in the segment or in a network in the data center. Mm-hmm. I mean, I as a human could never manage this. So yeah, I'm really excited to see what ACI can do. And you mentioned overlays. If you can explain what that is as well.
Yeah. So we'll hit the overlay one first. So there's this concept of underlay and overlay. And so we build a physical network someplace. And so we'll use Google as an example here for a second, because this is running in Google's data center, some cloud. I don't even know which one of their data centers, but it's in one of the Google data centers. And they have physical servers, and they've got physical networking gear that connects these physical servers together that provide their cloud service. So we're going to call that the base underlay, is the Google network that provides connectivity to all their physical servers. On top of that physical underlay network, there is an overlay that allows all of the virtual machines that customers of Google, like myself or like DevNet, to build networks where all of the virtual machines can talk to each other that are there. And so that's that first layer of an overlay. So I've got my physical network, and then I've got the virtual network that allows my cloud VMs to talk to each other. And then on top of that overlay is where the Kubernetes overlay pops up. Is there's actually another network that's built over the top of the virtual network overlay. So all of these containers and these pods can talk to each other inside of Kubernetes. And so that concept of an overlay is it's building networks on top of networks as they go through. And overlays are important to how kind of networking.
Hank, I've lost you. I don't know if you can hear me.
All right. So, David, we had a bit of a power outage here at my house, but we're back up. And to finish the thought and the concept on overlays, overlays are fundamental to how networking is going to go through kind of in the future. If you're trying to fight the overlay model completely, you're probably not going to be too successful, because it's just so necessary for the layers of abstraction and ownership differences and demarcation points between kind of underlying cloud providers, and then cloud and microservice platform owners, and then finally application owners. What's important about overlays is figuring out how you work with them so that you don't lose the ability to have the visibility and the segmentation and security. And that's the piece that we're going to dive into here as we kind of take this next step, is to look what happens when I combine the containers and the Kubernetes that we went in with a data center solution designed for this type of a model, such as Cisco's ACI solution, where we can actually link the networking from ACI into Kubernetes to see how it goes through, which is where we're headed next, if you'd like.
Great. Yeah, great.
Excellent. All right, so the first thing I'm going to do here is I'm going to switch over. I'm going to change my terminal window so that we're actually on a different cluster, because now we're looking at a Kubernetes deployment. And again, we've still got that same My Hero application we've been looking at. But now this is actually running a Kubernetes deployment out of a data center on an ACI fabric. And so let's look at the...
Just interrupt you for 1 second. Sorry, Hank. Just to
of course.
Yeah, so you've mentioned a few times Kubernetes cluster. I'm assuming that's just a bunch of VMs that give you functionality, or bunch of, well, what is that? What is a cluster, a Kubernetes cluster?
That's a great question. So I'm going to do another kubectl command. So kubectl get nodes. And so the get nodes command went through, and we can see that it returns back and shows me 3 nodes. So this is my Kubernetes cluster. The Kubernetes cluster, you can think of it like a vCenter farm or virtualization farm. And a Kubernetes cluster is going to be made up of one or more what are called master nodes. The master node is kind of the brain, the orchestrator. It's what you interact with. It's the kind of the vCenter in our analogy. And then there will be the worker nodes. The worker nodes are all like the vSphere hosts. That's where the containers are actually going to be spun up and run, and kind of where all the heavy lifting goes through. Now you can have a Kubernetes cluster that's as small as, remind me later. You can have a Kubernetes cluster that's as small as one node, where you've got the master and the worker kind of all on one piece. I would say that that's only really used for kind of testing development types of pieces. In a production cluster, all the master roles will be separated onto different nodes, and then you'll have a set of worker nodes that go through. And so in this example, this one here that ends in Kubo1, so SBX04 Kubo1, that's my master. That's where all of the logic, the orchestration will take place. And these other guys, O2 and O3, those are the worker nodes. That's where the actual containers are going to be spun up when we deploy things. Does that make sense?
Yeah, that makes a lot of sense. And sorry, I'm going off on a tangent here, but just to make sure that I understand, if you can go back to your other screen, you mentioned about... this is running in Google's data center. So like the analogy you used was Google have obviously physical hardware, routers and switches and servers that connect everything together. Then you've got VMs, which would perhaps be owned by DevNet. And then you used a great analogy. You said, the different components are owned by different people. So Google would own the infrastructure. DevNet would perhaps be in charge of the virtual machines, which gives you your first overlay network, and then you running an application on top of that and doing a second overlay. So we've got like 3 separations here of different people or organizations, and hence the need for overlays. Is that correct?
Yep, and that's part of the ones that go through. And you can actually go higher than 3 depending on kind of where the tiers are and other pieces that are there. Yeah. But I think 3 is a good way to kind of get it, right? Physical layer, virtual machines, then the Kubernetes pieces. 3 kind of clear spots for overlays.